Hi, good evening, students. We'll continue our previous class. Okay, in our previous class, we just gone through the single linked list. It's a forward single linked list. Okay. Now we'll go for the another type of a linked list is the circular linked list. Okay, the name itself it says that circular is nothing but the linked list is not like a line; it is like a circle. So in the circle, there is no starting and there is no ending. So the start and end are combined and which forms as a circle. So that will here we cannot use the linked list without starting and ending. So that we will combine the start and ending points of the linked list and to form as a circle. So for every time I will assign the last node next as the starting node. Okay, so that it forms as a circular linked list. Okay, that there is only difference in the single linked list and circular is the last element next element is the starting element of the linked list. Okay, then that is called as a circular linked list. In the single linked list we have the last element next is the null, but in the circular single linked list last element next is the first element. Okay. Okay, these are frequently used within the general linked list. Instead of the general linked list, we can use the circular linked list without going from the starting to ending and ending to starting with a for loop. We can directly move from the start to end and end to start using the circular linked list. So for that, we can use the circular linked list than the single linked list. Okay. Just we'll see how to use the different operations in the circular linked list. Okay, all the operations are similar and similar coding we will use in the single linked list of the single linked list code in the circular linked list also. Only the difference is for each and every updation of the data in the circular linked list, we will update the first and last pointers also. That is starting pointer and ending pointer also. Okay. This is a picture of the circular linked list. There is a start variable which points to the first node of the list, and 10 is the first node, and 20 is the second node, 30 is the third node, and 40 is the fourth node. So the 40 next, that is 40 node next variable and value is assigned as the 100. That is the address of the starting node. That is 10 node address is the 100 which is assigned as the 40 node next value. Okay, so that it forms as a circular linked list. The last node is points to the first node. Okay, this is only the difference in the circular single linked list. The basic operations of the circular linked list are same operations: creation, insertion, deletion, and traversing. Okay, as in the same way in the single linked list, we'll create the circular linked list, we will insert a new node in the circular linked list, and we can delete a node, and we can traverse the circular linked list. Okay, we'll start that operations of the linked list. Okay, here for creating a circular linked list with the n number of the nodes. So generally the steps are first we will create a one new node. So for that we can use the get node function. New node equals to get node. So get node function it creates a new pointer variable, one pointer variable of the structure type, and malloc is used to assign the memory, and then it assigns the value to the data variable, and the next variable is by default assigned with the null. Okay, now this new node pointer is returned from the get node function that is assigned to the new node variable. Okay, so then we will, if the linked list is the empty, then we'll make this new node as the starting node of the linked list. Okay, if the linked list is not empty, that is if the start is not equals to null, okay, then we will move the linked list up to the last node, and then we will assign the nodes to the will assign our new node to the last. Okay, this is actually in the case of the normal linked list, but to add a node in the ending uh, to the end of the linked list, we need not to check up to the null. We need to check up to the temp of next not equals to the start pointer. Okay, that is until unless the temp of next not equals to the start, we will repeat the loop. And whenever it becomes equals to next, then we will assign our new node to the temp node next. Okay. Inserting a node in the beginning. Okay. So inserting a node in the beginning is again we will take a one node from the get node function. Okay. So I will take a node with the get node function. One new node is created and assigned to the new node variable. And then we will make, if the linked list is a null, then we'll assign the node as the starting node. And new node of next is equals to the start. Okay, because we are assigning the new node as the starting node, and we are creating a circular linked list, so that new node next is again the start node because it forms as a circle. Okay, so we assign the start equals to new node and new node next as the start. Okay, so it forms as a circular. Okay, so if list is not empty, okay, then we'll take a one temporary variable as the last and assign the start to the last variable. And if while we will repeat the loop up to the last of next is not equals to the start. Okay, the current node next is not equals to the start, we will repeat the loop. That is, we'll move from one node to another node with the last equal to last of next. Okay, whenever the current node next is becomes as a start, then we'll stop the loop and we'll assign our new node. So new node next becomes the start and start as the new node. That is, new node next as the start node. I will assign the start as the new node next, and we will assign the start as the new node. And last of next is also the start. Okay. So our starting node is again updated to the last of next. So last node, next node is the start node. Okay. So we are adding the node at the beginning, so that we are adding the node in the start. Okay. So we updated the starting node so that we are assigning that start as the last node next. Okay. Yeah, this is the code remaining the similar code of the previous one. So only the difference is the last line, last of next equal to start. This is only the different. The remaining all the code is same as single linked list. Okay, inserting a new node at the beginning. 5 is the new node. 5 next is the 100, that is the 10 node address. This is already existing starting node. That starting node address is assigned to the new node next, and our new node is assigned as the last node next. That is, 500 is assigned as the last node next variable. So our last node next is the our current starting node. Our current starting node is the 5. Inserting a node at the ending. Okay. So for this also we'll create a one new node first, get the new node using get node function. New node equals to get node. It gets a one new node from using a get node function. Then we'll check whether the list is empty. If the list is empty, assign the new node as the starting node and start as the new node next. So which forms a circular. If list is not empty, then take a one temporary variable as the start and check up to the temp of next is not equals to start. So the current node next is not equals to the start. Repeat the loop. Okay, once it reaches to the temp of next is equal to start, then it stops the loop and temp of next is equals to our new node. That is whatever the last node is there. Okay, that node next is the our new node and our new node next is the start node. Okay, so our new node is added at the ending so that our new node next as becomes as the start node to form as a circular. Okay, so temp of next equals to new node. This is the normal code, the single linked list code. Just we are adding a one more line as new node next equals to start. Okay, to join that or to combine the starting node address to the new node next. assign the starting node address as the new node next. Okay, inserting the node at the ending. So after the 40, we are adding a new node as the 50. And this node address is assigned to the previous node, that is the ending node. And at the same time, we will assign the last node, that is 50 node next as the 10 node address. Okay, is this clear? And deleting a node at the beginning. So in the beginning, if you want to delete a node, okay, so for that, just we will delete a node in the beginning node and we'll update the start pointer and last variable. Okay, last node address and first node address we will update. So for that, take a last equals to temp equals to start. That is, we are taking a two variables, last variable, temp variable, both are assigned to the start. So while last of next not equals to start, that is, we are moving up to the last node. Okay. So until unless the last of next not equals to the start, move the last variable. And once it reaches to the ending, okay, once it reaches to the ending, then we are assigning the new, and then we are deleting a node. Start equal to start of next. That is just we are changing the value of the start pointer as start equal to start of next. That is next node of the starting node is assigned to the start. Okay, now the starting node is the second node in the linked list. Okay, so that we will assign this start node as the next node of the last node. So last of next equal to start. So our new start node is assigned as the last node next. So just we are moving a start variable to the next node and where the updated value of the start is assigned to the our last node next. Okay. Next, deleting a node at the beginning. Okay, just we are assigning a start equal to start of next. So that 20 node address is assigned to the start. And now we are updating our last node next as the start. So 20 is 200 is assigned to the 40 node next. And deleting a node at the ending. Okay. So if you want to delete a node at the end of the list. Okay. If the list is empty, then display a message as empty list. Okay. If list is not empty, take a temp variable and previous variable. Both are assigned to the start. So we'll move up to the temp of next is not equals to null. Okay, in general, we'll use in the linked list as temp of next equals to not equals to null, but here we'll use the temp of next not equals to start. Okay, so here we are taking a previous equals to temp equals to temp of next. For every time, whatever the node at present is there, that we'll assign to the previous prev variable, and temp is moved to the its next node. Okay, this loop is repeats up to the temp of next not equals to start. So once the temp of next becomes the equals to the start, then it stops the loop and exits from the loop. Okay, now here we are assigning the previous of next equal to start because we need to remove the last node. So last node previous node address is assigned to the prev variable. So that previous node next becomes the our starting node. That is nothing but the last node address is removed from its previous node and starting node address is assigned as the next of the previous node. Okay, so that last node is deleted from the circular linked list. Okay. Okay. So here we are deleted the 40 node. 40 node previous is the 30 node. So 30 node next as the start. So 30 node next is becomes as the 100 address. Okay, so that 40 node is removed from the memory. Okay, and traversing the circular linked list. Okay, just we will traverse from with the temp equal to start and we'll repeat the loop until unless temp not equals to start. Every time we'll take the value of the temp node, temp of data, and we'll move the node from the one node to another node as temp equals to temp of next. Okay, if the list is empty, we can show the empty list message. Otherwise, we can traverse from the one node to another node. These are the advantages of the circular linked list. The main advantage,